Alright, now we have the IK chains, so let's have a look at the clips. I'm going to start by removing all this crap. We don't need it anymore. And another thing I'm going to do, I'm going to go to the agent layer, and I don't want to see the groom here. So I'm actually going to not have it as the current layer, like so. Alright, okay, so let's drop down an agent clip node. And in here, I've got some B clips. So I'm going to go to File. I'm going to go in here. And let's see what I have. I have a run clip. So let's start with that one. Call it run. And I am going to look at it with the clip preview. Set it to run. And we can see it looks alright. It's maybe I would want to have it more centered, but at least it's in place. And if I use this apply clip locomotion, so now it's driven by the clip motion that you stripped away to the locomotion channel. So that's good. Let's see what else we have. We have, let's go to file, and then we have this left and right. Let's have a look at the left first. And the whole, look at the left one here. We see that we have this arcing motion. And you can also see that he's leaning in to the turn. What you can do with this is to set it up as an arcing clip, which means that even if you only have a run state, when the agent turns, it will start to bend over to the arcing clips, and in that way give the agents a more natural way of turning. One problem with this clip though is if I turn this off, he's not in place, and the locomotion channels are empty. So instead of having his point position be driven by the locomotion channels, the point position remains in the center and the rigs moves away inside the clip. Hopefully this will make more sense in a second. You might say, yep, so what? That's important, and it is, and I'm going to show you why. So let's first take the right one as well. And I'm going to do here, I'm going to do right, and the same thing there. If I could go here to right, he's just going to run the other way. The same thing here is not in place. So let's set up a little simulation and see how it looks. Let's do a crowdsource here. And I'm going to have 10 horses. I'm going to set initial state to run. And then I'm going to drop down a dopnet. And here first we need a crowd solver. And then a crowd object where the geometry is. And these days you actually don't need a crowd source anymore. You can just go to the source here on the crowd object and set that to first contact geometry. And it looks a bit messed up because we don't have a state. So let's drop down a state, crowd state. That goes to the third port here. And let's call it run. And in the clip name, let's do run here as well. By default, if we just play this as is, you will see it's not really synced with the clip. That is just because this in place thing. So you could change the gate speed because it's a constant speed in the clip. So theoretically you can actually get it to match what you have in the clip. But why not just use locomotion? We have the locomotion channel, so we can just use locomotive, and then it's just gonna play it how the animation is within the clip anyway. So that's cool. And then we're gonna put some variants, and let's do a random offset. And now we have these guys running. And let's constrain the frame rate as well. Cool, that's good. And we also want this to turn now. So I'm gonna go out and just draw a curve. I'm gonna put snap on to the grid here. And if you have a path you want them to follow, it's a good thing to have them on the path in the beginning. So I'm gonna start behind them, something like that, and then I'm gonna turn. So I'm gonna do a null here, path, and then in here I'm gonna drop down a pop steer path, and I'm gonna point to that path, path, and now they should be following the path. So here they come, and here they turn. And now you see they look very robotic when they turn around. To add that clip arcing, you use a clip arcing sub. So put that in here, and then you can add the clips. So let's start. Turn direction is left to the beginning, and then you have the radius, that is how much they are turning. You can have more than one left clip that have more extreme turns, and then you can layer them up. But in this case, we're just going to have one for each direction. So let's choose left here, and let's play it. Here you see why it's not working. The reason why it's not working, because these are just blending. So if I go into crowd object here and just have a look, and I go to show the clip names, and I'm going to show the clip weights. See, if I don't have this clip arcing player and go to the beginning, I just have the run, and then you have the weight for that run clip, so it's 100%, because that's the only clips it's playing, so it's not blending with anything. But when I turn this on, suddenly it adds this left clip as well, so it's actually playing at the same time. And then you have the weight value here. So when this is 1, then it's just blended completely over to the left, and then you have like everything in between. When we're starting here, we can see it's starting to blend. So these guys, they are actually in the same position if you would just look at the point position. So you can see here is the point position of these guys, but because these guys are moving within the clip, they are moving away from the point position, but while the default run is at the point position, because the point position is driven by the locomotion channel, if that makes sense. We need to strip out the motion and have locomotion even for the arcing clips. So let's see how we can do that. So let's go out. One thing we can notice here in the agent clip is when we take an FBX or a character rig, for example, then we have these different options to convert something to locomotion. But because these guys are already processed, there's nothing you can do like within this node. But what you can do with clips is you can always change them in chops. So let's drop down a chop net. So here's a chop net, and then let's make a null, and we have them out clips here as out clips, and let's make that black as well. And then within the chop net, let's drop down an agent, and this is how you read the animation curve from a clip. So then we can point to these clips. So we go to out clips, and then you can just select what clip you want to use. So we want to use the left clip here, and if we select this here and look in the motion effects view, we can see all the animation curves. In this case, if we just look at the locomotion channel, so let's go in here first and have a look at the locomotion. Like in here, you have this star mesh. You can actually just do star locomotion, or you can just do star loco in this case, like that. That means like everything that has loco in it will be deleted. We won't have the other way around, so non-scoop channels. And in this way, let's go to graphs and graph single per channel. And here you can see the locomotion channel. In the locomotion channel, you have the translation, you have the rotation, which are the R channels, and then you have the scale, which you don't really use. So that's for locomotion. So where is the motion? And in this case, if we look at the rig, we're going to have the animation here on this SRT. So if we go back in here and then drop down another delete, and then we do SRT star, so we get all the channels. And here, if we look at this now, and then also non-scoop channels, now here we can see we have all the motions. Do all scoop channels here, all the motion for the horse when he's running around and turning. So what we want is we want to have all this in this locomotion. So to do that is actually quite easy. We just need to rename the channels. So I'm going to drop down and rename. I'm going to take these channels, and you see we have this reference. You could do just rename from, and you could type locomotion to SRT star, and that would work. But we don't even have to do that because we have the same amount of channels. You can just use this name reference. So then we take these guys, say we want to have the name of these channels for these channels. Now they are called SRT, and then we can do the other way around for these guys. So now these guys will be called locomotion. Cool. Okay. So then you merge these together. So now we have a locomotion channel, we have the SRT channel, they are fixed, And of course, we need all the other animation curves as well. So then I gotta drop down another delete. And in here, I say take all channels in here, but I don't want the SRT and I don't want the locomotion. Now these channels are stripped out of these guys, so I can just merge them in here. And then we do an out. I'll call it out left. I'm gonna make them black as usual. And if we go out here to the scene again, oops. I'm gonna copy this agent clip node, have it here instead. And here for left, instead of file, I'm gonna go to chop. And I'm gonna go in here in the chop net, take out left. So now we have this new animation clip we made. And if we look at the left one here, can see it's actually in place now. So now we stripped away the motion, and if we would apply clip locomotion, we can see that we have that motion within the locomotion channel. Excellent. So we just need to do that for the right clip as well. And let's go in here, right, out right, and I'm gonna call this left. So, okay, and then I can go back in here, oh not in here, here, and I go right, go chop, go in here, do out right, cool, and if we would look at this now, you will see that it's a little bit better. You still have something really weird going on. And one thing we're actually going to do, we're going to go in here and turn off the avoidance. This is also because it's sensitive, because they are turning really fast right now. There's fast changes in how it's turning, so we can constrain the turn acceleration, and then it's going to look a little bit better. So now it's not as jittery, but still it's not that good either. So if we look at, let's see if we can find someone. If you look at that guy, for example, you see something really weird is going on there. But this is the first step, so let's have a look how we can fix the rest of it as well.